Hello everybody. Today we are going to talk about the homogeneous system. In homogeneous systems we have three types, which the eigenvalues of the coefficient matrix will decide which case it is. We have three cases. The first case is real and distinct eigenvalues. The second case is real and equal eigenvalues, and the third case is complex eigenvalues. Today we are talking about the real and distinct eigenvalues, and we will take an example about it. Real and distinct eigenvalues. It means we have a matrix, a coefficient matrix, let's say A, it's an n by n matrix, and when we find the eigenvalues of this matrix, we will find that we suppose that it is the first case, so we say that lambda 1, lambda 2 until lambda n, they are all real and distinct eigenvalues. All we need to do is finding the eigenvectors associated with the eigenvalues respectively. Let's say beta 1, beta 2 till beta n. They are all eigenvalues, eigenvectors associated with the eigenvalues respectively. So we have to multiply each eigenvector by e to power the corresponding lambda, the corresponding eigenvalue t, or any variable that we haven't used it in the system. So this will be e to power lambda 2 t till e to power lambda n t. Then we put all there are also vectors. We put all the vectors in another matrix, let us say psi of t, because it contains t as a variable. Then this matrix is e to power lambda 1 t, e to power lambda 2 t. Each vector here is like a column here, and this matrix is called the fundamental matrix. If you find the fundamental matrix of any system, then you can find the general solution for the same system easily. It is all about the real and distinct eigenvalues. I think it is the simplest case. Now let's solve an example about the real and distinct eigenvalues. Let's take an 2 by 2 system. Let's say it is example about it. Say y1 dash, y1 dash, y2 dash, it is equal to y capital as a vector. It is equal to 2, 1, 3, y1, y2. It is a 2 by 2 system. We have to find the eigenvalues and then eigenvectors, and multiply the eigenvectors by e to power the corresponding eigenvalue t. Now, to find the eigenvalues, we have this, actually the determinant of A minus lambda I, which is identity matrix, lambda I, the determinant of A minus lambda I equal to 0. It's following that 2 minus lambda, 2, 1, 3 minus lambda is equal to 0. Now, solve the determinant, you get that lambda squared minus 5 lambda plus 4 equal to 0. It is a polynomial of degree 2, and it is clear it has 2 roots, and the roots will be the eigenvalues. Now the first eigenvalue is from this. Lambda 1 is 1, lambda 2 is 4. It's very easy to solve the second degree polynomial. Now we have to find the eigenvectors associated with 1 and 4. For finding the eigenvectors, we have a formula that say the matrix it is not determinant A minus which lambda we work with is lambda 1 I, and we write an arbitrary matrix vector, let's say b11, b21. It is just name, you can take any letter, and is equal to 0. What you get is write down this. Write this. I minus lambda 1 I is what? Here is A. Here is A. And lambda 1 is equal to 1. Multiplied 1 times identity is also identity. Then we have 2 minus 1. We have 2 minus 1. 2, 1, 3 minus 1. And multiplied by b11, b21 equal to 0, 0. And what we have, it is equal to 1. 2 minus 1 is 1. And 3 minus 1 is 2. Now we have this matrix. Now we create a system by multiplying the matrix and the vector. We have b11 plus 2 b21 equal to 0. b11 2 b21 equal to 0. And again b11 plus 2 b21 equal to 0. It is the first equation, it is the second equation. But the equations are equal. It means we have only one equation. If you have one equation and two variables, it means we have one free variable. We have one free variable, and you are free which variable you take as a free variable. Now we have from these b11 is equal to minus 2b21 minus 2b21. If you take b21 by minus 1, let b21 equal to minus 1. Thus, put it in equation I, you get b11 is equal to 2, because it will be minus 1 times minus 2, and it is equal to 2.